I've hired too many developers that blindly refactor code and leave it in a state where every other dev on the team thinks it's worse now, not better. There are 7 deadly sins of bad refactoring. Let's talk about what good refactoring looks like and bad refactoring patterns to avoid, so you don't have to be that teammate that everybody hates. The first thing to avoid is not following the patterns already used in a code base. So let's take this code. It definitely could be cleaner. I hired someone once who refactored a bunch of code like this to use a functional style they preferred like this. The problem was they actually added 2 new libraries to do this, and it was just a style that nobody else could relate to or had experience with. Every piece of code they touched, they moved into this style, and then when other devs needed to come in and work with this code, it was really frustrating and annoying. A better approach would be to do something like this. This is pretty conventional JavaScript TypeScript. This is what the rest of the code base generally looked like. And that's not to say that adding new libraries and patterns is bad. Just get buy-in first. Talk to your teammates about the benefits of new conventions. Get their inputs. Maybe they don't like rammed up, but they do like the functional style, and maybe another library would be suitable. And then align with them on how we want to introduce these new patterns and how eventually we bring back consistency to the code over time. Don't just go rogue and assume that you're doing it the better way. The next problem I've commonly run into is people who had unnecessary abstractions. So back to our original code example, a bad abstraction would look something like this. We added a class with properties and methods, breaking every single piece into its own piece of logic, and needing to construct this user processor and call the process method. It's just a lot more than is necessary, when all we really need to do is this. We'll pull out this isAdult function and this format user function, and we'll simply call filter and map on it. We just don't need more layers than that. A related problem to that one is also overly consolidating code. You might see repeated code in a code base and say, hey, let me bring that together. And if there are inconsistencies, you might assume those are unintentional and can be simplified and consolidated. I hired someone one time where the first thing they did when working on an API is refactor a bunch of API code into one create API wrapper. But can you see the huge problem with this code? When we started deploying APIs started breaking left and right. That's because different APIs needed different options. Some needed more memory. Some needed to run longer. The fact that they had different settings wasn't a mistake or sloppy coding. We started with general defaults, and we made modifications when we realized the APIs needed different settings. A better abstraction is one where we pass through the options so we can customize the options per API. So we consolidated redundancy and made global changes in the future easier, but we didn't remove every API's ability to customize itself for its needs. Had we done this, we might have saved a lot of headaches and downtime. Which leads me to the next issue, is not understanding the business context before making major decisions. One time I joined an e-commerce company on a wildly legacy tech stack. I mean, this was using like an 8-year-old Java framework that didn't even have documentation online anymore. I convinced them to use something lighter, faster, more modern. Angular.js. The problem was I was new to this business, and I didn't know this was a heavily SEO-driven business. We migrated them to a single-page application, and SEO and conversions took a huge dive. We adopted tech that I liked. That was a very bad idea for the business. Had I understood this business context, I would have undoubtedly recommended something that has server-side rendering support, and we could have saved a lot of headaches and a lot of dollars. Which leads me to the next common problem, which is just not understanding the code before you refactor it. Generally speaking, you should probably be working with a piece of code for months before you have the boldness to feel that you know the right way to refactor this code. Most of the problems I've encountered are ones where the person just hadn't worked with that code and automatically assumed that just because they didn't understand it, it must be bad code, and they should just refactor it before even learning it. That's where most of the big problems have happened. And even if that code was in a messy state, don't be that engineer who adds new bugs, new performance issues, and new headaches for others on the team because you refactored blindly. Let's take this code, for example. It's a little ugly, and it can be better. A blind simplification of this code might look like this. Why didn't we need all that JSON stringify local storage? Let's just get rid of it. This is simpler and more beautiful. The problem is, most code starts out simple and beautiful, and then you realize maybe it's slow, maybe it had a bug, maybe it didn't behave as optimally as it could. That previous code added caching logic for a reason, because at a certain point in time, people found that it was necessary. Perhaps this is a better way. We added our own basic cache manager to encapsulate that logic. We added an expiration feature, and we didn't lead to any new performance problems or bugs or anything like that. Lastly, let's try to avoid adding inconsistent patterns or style to a code base in general. Let's say we have a code base that heavily uses React Query. But let's say for a new component, one of our React devs really wants to use Redux and just goes ahead and adds it. The problem is, maybe I don't know what a dispatch is or a selector is. All the other code works a certain way. But now any developer that jumps in here has to work with this. They may not like it, they may not understand it. New bugs and issues can come as a result of that. Or you could just follow a consistent approach. Remember, you can always talk to your teammates and get their input on adding a new pattern. But without buy-in, This can be really frustrating and lead your teammates to be annoyed with the way that you approach this problem and just disliking working with your code in general. No code base is perfect. All of them need cleanup. But do your best to make sure that your cleanup leaves the code in a better state, doesn't add new bugs or performance issues. And a few tools that you could use to help you out is one, writing unit tests. So you can be sure that the new code correctly matches the behavior of the old code. If there aren't tests, add them. People will appreciate that, and you'll have better confidence in your refactors. Second, use type-safe languages. Having a type checker assist you can help avoid a lot of unnecessary silly mistakes. Third, use pull requests and code reviews to give and receive feedback about your code updates. And fourth, use tools that understand the importance of coding style and conventions. For example, if you use Visual Copilot to turn designs into code, it not only integrates and understands your existing components and reuses them, but you can also provide code snippets and detailed custom instructions to have it match your coding style. So if I don't like that React.fc format it last used, I can have it generate using this simpler function syntax, which our team prefers. And that's it. If you want a deeper dive on this subject, I've got all these code examples and more in my latest blog post on the Builder.io blog. And also, what other refactoring tips do you have or common mistakes that people should avoid? Let me know in the comments, and I'll take the best ones and I'll go add them to the blog post. Happy refactoring, everybody.